Alright, so I welcome everyone to this class on statistics. So we'll be looking at the topic sigma notation and measure of central tendency. So let's begin with sigma notation. So what is sigma notation? So what sigma notation is all about is usually refers to this expression here. The symbol we have here is called sigma, and it simply means summation. It means we're summing a set of numbers right from the beginning to the ending. So just look at the expression when we have this here, this symbol here, that which is the sigma notation, and x subscript I. So the I is telling us that okay, x is a number which begins from 1 up to n. That's just it. So we can have a number which is x1, we keep summing it, plus x2 plus x3 x4 up to the value of n. If n is 3, so we stop at 3. If n is 4, we get that to 4, x4. So that's just the idea of sigma. So we need to sum. We simply need summation and sum everything down that way. So that is the idea of sigma notation. So let me give you an instance here. When we simply have let's say for instance we have our sigma notation. So we have our sigma notation, and we have x subscript I, which is simply I. It can be any algebraic letter, and so we have, and given that I is a value from 1 to 3, that is the value of I, 1 to 3, and also we are given that x1, our x1 is equals to 5. In the illustration, we're given that x2, our x2 is equals to x2 is equals to 8. That's the given value, and as well we're given that x3 is equals to 11. That's just the given value there. Alright, so of the expression. So since we are given that, so we know that summation, the sigma notation here, the summation will simply be x1 up to x3 up to the value of I. So x1 plus x1 plus x2, so plus x3. So that will simply be the summation. So, and that will be equals to, so what is our x1? X1 is 5. We have that to be 5, plus what is our x2? X2 is 8, plus what is our x3? And our x3 is 11. So in all, we have that to be equals to 24 as our final answer. So that's just the idea of a simple idea of sigma notation. So we have that to be the final answer, which is 24. Can you see? It's very easy and direct. So let me wrap this up so that we can have clarity. So I think you get that. That is just the simple illustration on that. Now, for us to get the idea of sigma notation perfectly, we need to understand some rule of sigma. So when you have the given expression here, you have the given expression, you are given the sigma x subscript I is telling you that you should sum the various value. X is the values that range from I being 1 up to n. So we are expected sigma being notation, that means you sum all of the values for which x is to carry. So x is a set of values, so we are expected to sum everything. So and that has been explained earlier on. Now the second rule is this. So when we have x and y, we have to sum x subscript I multiplied by y subscript y. So that means x and y are a set of values, a set of values, and in that regard they have their values, and we're expected to sum them right from when I is 1 up to when n I is what is the value for n. So if n is 4, that means we have to sum it from when it is 1 up to 4. So it's easy and direct in that regard. So that is just it. Okay, let me give you an illustration on that. Let me give an example. Let's say for instance we have the sigma notation. We have xi and we have yi as well, and okay, you were given that I is a value, I is simply a value, is a value from 1 to 2. Let me just make it short because of time. It's range from 1 to 2, and as well our si is equals to let's say is equals to 3, and y1 is equals to 2, x2 is equals to, let's say that is equals to 5, and our y2 is equals to 4. So we can have that to be equals to, so x1 y1, that will be that s1 y1 plus x2 and multiplied by y2. So we have that is, and everything will be equal to, what is our x1? x1 is 3 multiplied by x2 multiplied by y1, rather y1 is 2. So we have that. So plus, what is y? x2 is 5 and y2 is 4. So, and in all we have that to be equals to 3 times 2 is 6, it will be equal to 6 plus 20, 6 plus 20, and that gives us 26. So it's so direct and easy. So I think you get that. So that's just the idea of sigma notation. That is the idea of sigma notation. So you can take your time and study that and how everything has simply been derived. So that equals to 26. So that aspect has gone. Another rule is this. So when we have a constant number, we have sigma. We have the sigma, and that is summation of a x with power I. So that means a is the constant values of the sigma. So we can simply factorize that out. So then use it to multiply all of each value of x. So that means x will range from x1, x2, and that means each value of x will be carrying a constant value. Just take that, and since each is carrying the constant value of a constant of a, you can factorize that out and simply sum it. So that is what this is indicating, is that when we have the sigma notation, then a s I, it can as well be interpreted to be a being a constant multiplied by the sigma notation, then xi. That's just the rationale behind that. I think that is well understood. So that is just the rationale. So we know this value, so we know this to give us this, which is actually interpreted. So that will be a times the value here, and this value we have here, and this value. So it simply give us this. So it give us this value we have here. So I think that is well interpreted. So it's easy and direct. Alright, so that is all about that law. Another aspect now is when we have, I think that is what I just explained now. So another rule is this: when we have the sigma notation, and that is the bracket summation of ax, then by. But just know that x is just a single value, not a set of values, since it doesn't have any subscript. So I think you get that x is a single value here. Alright, so when we have it's only when you were just told that s range from from where s is equals to 2, 3, or x, any value for x, just be it interpretation as well has been given to you. Alright, so when we have x ax and by and this, so that will be equals to, so since the sigma is into brackets, so each of the expressions summation can take each, the sigma can take each, so that will be the sigma, just like I opening a bracket. That's just the logic, the idea there, the logic behind that. So that is sigma of ax, then sigma of by minus sigma of c y z. So we by ax, y, z are variables, so we can just bring each of the constant out. A, B, C are constant, so you can bring them out to serve as the product of the sigma, and we have this. Okay, let me give you an instance, an example that will actually specify that. Let's say we have a sigma notation here that specifies that a x as been given in that law plus b by minus c z, and you will now know that ax is a value, x values are this 2, 7, and 5. Those are the given value for what, for x, according to the rule. And as well, y are values that range from 8, that is 8 actually, comma, no mind my handwriting, 5, comma, and 2, and 4. Let's make it 4, and z a set of values that are 9, comma, 12, 9, 12, and 7. So an a is equals to 5, being a constant, as well b, I think you know that this is b is equals to 6, and c is equals to 7. So we are asked to find the value of this given expression there. So what will be the value of this, considering that? So that is very easy to calculate. Also, just remember our law, that is this sigma notation here, this expression here, a x plus by then plus minus rather c z we equals to a summation x or sigma x plus, we bringing the constant out, b summation y and minus c summation z. So we are going to have that. So, and that will be equals to, okay, we can see, so what is summation x? Let's get that first. Summation x will be, which summation value for x? That will be 2 plus 7 plus 5 plus 7 plus 5. So we have that to be 14. So that will be equals to 14. So we have 14 already. So summation y summation y. So what is summation y? Summation y will be 1 plus 5. Oh, that is 8 too. 8 plus 5 plus 4, and that gives that give us 17. And then summation z, that will give us 9 plus 12 plus 7. So that will give us 28. Alright, so then the final answer for this will simply be equals to 5, which is a, following this law, 5, which is a, multiplied by summation s, which is 14 rather, so 14, so plus b value is 6, multiplied by summation y is 17, so minus minus 7 multiplied by summation z, which is 28, so 28. So we can then multiply 5 times 40 is 70, 5 times 40 14 is 70, 6 times 17, I don't know that, let me use calculator quickly. 6 times 17 is 102 plus, okay, minus 7 times 28, 7 times 28, that gives us 196, and that will give us the final answer of minus 24. We have a final answer of minus, so the summation is simply minus 24. This is our final answer here. So I think that is well understood. So I think you get that. So this final answer we have in minus 24 is simply the summation of this, given this expression of values here. So I think that is well understood. So let me quickly rub this off. So I think you get that now. So that is just the idea of summation. Summation is easy and direct if you can practice more and learn their rules. So I think you get that perfectly. So another rule, I don't think we have another set of rule. Okay, that is all about the rule. Now let's move to the cocoa of this class, the major aspect, which is on measure of central tendency. So measure of central tendencies are measure of averages. They are measure of averages that enable us to measure averages. They enable us to determine how data are being centered within the distributions or around the distribution. So we can measure the mean, the median, and the mode. They are good measure of tendency. So let's move to the first aspect, which is on mean. So mean is the common average. When we talk about average, we try to talk about mean. And our measure of mean is the common measure of averages, and the mean can be in form of arithmetic mean, geometric mean, and harmonic mean. So just take it that for this class, our arithmetic mean will be denoted as AM, which is the common aspect of common mean, common calculated mean. So we have GM for geometric mean, and then HM for arithmetic, harmonic mean for harmonic mean. Alright, so HM for harmonic mean. So for arithmetic mean, we can have the sum of all values from x1 to xn divided by total number of values. So in our sigma notation, we can have our mean to be summation of x to n, especially when we have for group data or data without frequency. Data without frequency, we can simply just sum all values of x and divide it by the number of observations. So that will give us our arithmetic mean. When we have a data with frequency or group data, we have summation fx divided by summation f, whereby f is of frequencies, the number of times the observation occurs. So each set of observation occurs. So we have frequency, which shows the number of time, number of occurrence of each set of observations. So that is the idea of frequencies. So we have frequencies here. So we have frequencies. So I think that is well understood. Now let's move to, okay, yeah, we use this for when we are given the aspect of assumed mean, where we assume the set of, okay, we have an assumed mean using this distribution, so we can use that to determine our mean. So when you are given an assumed mean, you can easily determine your mean. So we are given an assumed mean, so you apply this. So with the given distribution, you have an assumed mean, you can simply use that to determine your mean. So assumed mean plus summation fd divided by summation f. Summation f is the total number of set in the distribution, where your d is actually given as the observation, which is x, minus the assumed mean minus a. The assumed mean minus a, s minus a is actually given as that. So I think that is well understood. It's easier and direct. I think you get that now. So let's move on to this. Maybe we'll move on to example. All right, so let's take an example on that. Okay, look at this example here. Find the arithmetic mean of 8, 2, 5, 8, 10, 6, 5, 12. All right, let's look at the solution. All right, solution. Then what is the given solution? So we have our arithmetic mean. Okay, I forgot to explain. This is the symbol for arithmetic mean. X is pronounced as x bar. So we use this to represent our arithmetic mean, am or x bar. So our x bar, which is our arithmetic mean, is equals to summation x to the number of observation, which is n. So we sum all observation, 8 plus 2 plus 5 plus 8 plus 10 plus 6 plus 5 plus 12, all divided by 8. And then when we sum everything together and divide by 8, we have our arithmetic mean to be 7. That is very, very simple and direct idea of arithmetic mean. So let's move to another example. Arithmetic mean continues. We still have more examples to take on that. So we have this example here that we are giving. The following is the distribution of age of 670 students of a school. Compute the arithmetic mean of the data. So let's look at the data. Okay, we have the data here. We have x in years. So the age, so these are the ages here. We have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and look at their frequency. So number of students that are of age of 5 are 25, number of students that are of age of 6 are 45, age of 7 are 90, 8 are 165, 9 are 112, 10 are 96, 11 are 81, 12 are 26, 13 are 18, and 14 are 12. are 12 in number. So look at the solution. We can look at our solution now. All right, we have a table. Just draw a table, a vertical table. So we have the ages here, which is x, all of the ages, and their expected what frequency. So we need to get our fx now, because if we are to get our mean, do not forget our formula in arriving at the what, at the mean, or at our x bar. We know that our x bar is equals to summation, as stated earlier, summation fx divided by summation f. So that's just the formula, the given formula, divided by summation f. All right, so we have that. So we have all our x values there, and their respected what frequencies. So we need to multiply. Firstly, we want to multiply this now. 5 times 25, that will give us 125. So 6 times 45, that gives 270. When you multiply 7 times 90, that gives us 630 as calculated. 8 times 165, that will give us 1320. 9 times 112, that will be equals to 1008. 10 times 90, 96, that will give us 960. And then 11 times 81, that will give us 891. 12 times 26, that will give us 312. 13 times 18, that will give 234. And 40 times 12, that will be equals to 168. So we have that. Now next thing is we need to find the summation fx. So we need to sum everything here together, and as well sum our f values together. So in that summation, so summation fx, we have that to be equals to 5198. So when we sum all values here together, that amounts to this. And summation f, sum every values here together, that equals to 670. So as given here, as the number of students given, so that means our x bar will be equals to summation fx all over summation f as given. So summation fs is this when we sum all values here together. So that gives us 5918 divided by 670, which is our summation f, and that will give us our averages, which is our mean, and that gives us 8.83. So that is the average mean mark of a student, or average mean age of a student is what is 8.83. So that is the average mean age, and it has a lot of interpretation. So this simply means in the school, our arithmetic means is always the expectation, the repeated number. So it means in the school, on average, we should expect that what a student should have a mean age between 8.83. So that's just the normal arithmetic mean. So that is done of that. So let's take another example on arithmetic mean. Alright, so let's take another example on that. So okay, calculate the arithmetic mean of the following distribution. Let's look at the distribution. Okay, we have it. Okay, for this is an instance of group data now. You know what the group data is. That has been explained in our previous videos or example or class. So we have to calculate the arithmetic mean of the following distribution. We have our class interval. We have a 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, and we have their respective frequency: 8, 3, 8, 12, 15, 18, 16, 11, 5. Alright, so we have the solution. So firstly, we have our class interval here. List out the class interval. So after listening out your class intervals, get your mid point, which is your x value. And how do you get a midpoint? You sum this and divide by 2. That has been explained earlier in the class. So 0 plus 10 divided by 2 will give 5. 10 plus 20 divided by 2 will give 15. That's 20 plus 30 divided by 2 will give us 25. 30 plus 40 divided by 2 will give 35. 40 plus 50 divided by 2 will give 45. 50 plus 60 divided by 2 will give 55. 60 plus 70 divided by 2 will give 65, and so on like that. So your f value, your frequencies, all will be listed, and you get your fx. So when you multiply 5 times 3, that gives 15. 15 times 8, that actually gives 120. 25 times 12, that equals to 300, and 35 times 15, that will be equals to 525, 45 times 18, that amount to 810, and we have 55 times 16, that will be equals to 880. 65 times 11, that equals to 715. 75 times 5, that will be equals to 375. Now we need to find the summation, sum everything here all through, and that will give us the total frequencies. And here we have to sum all of the fx together, and that will give us our summation. So that means summation f is 88 and summation fs is equal to 3740. So 3740. So we can get our averages now, our arithmetic mean, at very easy. So our x bar, which is our arithmetic mean, is equal to summation fs over summation f, and summation fs is 30740, and summation f is 88, and when you divide that gives us 42.5. So this is simply the words. This we have here, it's simply the what? It's simply the arithmetic mean, the average what? The average our expected value. Let's move to another section of the class, which is on geometric mean. So for geometric mean, it's always the end fruit of all product of observation. Instead of finding the summing all of the expression and divided by the number of observation, which is in our arithmetic mean. But here we take the end truth of the product of the observation. So what does that mean? So for each observation, when we have x1, x2, x3, we find their product and take their end truth. So it's always the end truth of the product of every observation. So it's the opposite of arithmetic mean, and it's also one of the way of finding averages or finding mean. All right, so let's take an example on that. So when we have this example here, find the geometric mean of 2, 4, and 8. So to get that is very easy. So we have a solution. So we can simply have that to be what is n? N here is simply n here from the how many observations do we have is actually 3, 2, 4, and 8. We have 3 observations. That will be the third root according to the nth root. So n is 3, the third root, or the cube root of 2 times 4 times 8. We find the product, and 2 times 4 times 8 will be equal to 64, and that will be the third root of 64, and that will absolutely give us 4. So the geometric mean of this is simply 4. Now let's move to harmonic mean. For harmonic mean, it's always the reciprocal of arithmetic mean of the reciprocal of a set of numbers. So that means we simply find the arithmetic mean of the reciprocal of a set of number. It always give us, that will simply amount to the harmonic mean. So that simply means we need to find the arithmetic mean of the reciprocal of each set of observation, and as well find the reciprocal of that arithmetic mean. So where we have a set of observation, we take the reciprocal first, each observation, and after taking the reciprocal, we find the arithmetic mean, and after finding the arithmetic mean, we now take the reciprocal of that answer. So it's the reciprocal, so that the reciprocal of the arithmetic mean of the reciprocal of a set of numbers. So it's this with reciprocal. So you can simply apply this formula. Yeah, we have this formula you can apply. It's n divided by summation. So this is the derivation here. We are expected to find the arithmetic mean of reciprocals of a set of numbers. So this is the arithmetic of reciprocal. 1 summation 1 over x, that we've taken the reciprocal of x and find their summations and divided by n. So this is it here. So we now find the reciprocal of that as well. So I think that is very direct. So when we simplify this, we have this as the formula. So when you find the reciprocal of it, that will give us n over this. So you can apply this directly. So do not forget this formula, n divided by summation of every reciprocal of a set of numbers. So that's just that. Let's take an example on that. So we find the harmonic mean of 2, 4, 8. So to get the harmonic mean, we have a solution. So we can then say, okay, why meaning we apply the formula n over summation 1 over x. So in applying that, so we can have 3 divided by, we summing the reciprocal of each, so 1 over 2 plus 1 over 4 plus 1 over 8. So when you sum 1 over 2 plus 1 over 4 plus 1 over 8 together, that will give you 7 over 8. So 3 divided by 7 over 8 will amount to, that will amount to, no, 3 times, find the reciprocal of 7 over 8, that will be 8 over 7. I will have 24 over 7 as the answer, and that gives us 3.43. So that is our geometric mean, harmonic mean of that system. So I think we are good to go. We are good to go to another areas of measure of central tendency, which is on our median. So for median, it's always the set of observation group which is at the center when the numbers of observation are being arranged in an array or in an array. So they are well arranged, maybe from the order of or from the magnitude of descending or ascending order when they have been arranged that way. So the set of observation that falls, the observation that falls at the center or at the middle is always the median. So the median of a set of numbers arranged in order of magnitudes is either the middle value or the arithmetic mean of the two middle values. So sometimes you can have two values to be the median, so we find that the arithmetic mean. So you sum them and divide them by 2 to get your median. Alright, so yeah, we have find the median of the following set of numbers. We have 8, 4, 5, 2, 8, 10, 4, and 6. We have the set of find the median. So first thing, to get that, we need to arrange them in order of magnitude, in order of size. You can arrange them in descending or ascending order. In the sense of ascending order, that means you have to arrange them from the lowest to the highest, and in the descending order, arrange them from the highest value to the lowest value. So we arrange the order in order of magnitude. So we arrange here now in ascending order. The lowest is what is simply is 2. This is an error. So this is supposed to be 2. The lowest there is 2, so we have 2 being the lowest. It's supposed to be 2. So the lowest is supposed to be 2. So we have 2. How many 4 do we have? We have 4 to be the next, and 4. We have 5 to be the next, and we have 6 to be the next. Then we have 8, 8, okay, 3, 8, and we have 10. Just arrange them well. So how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So and we have whether the median is then 6. So to have the way simply get that, so we can always say we have n divided by 2, and we have 9 observation. So we can then say, okay, 9. Okay, we can just put plus 1, especially if the set of numbers are, if set of observation are simply odd. So plus 1 over 2, that will give us where the median actually falls. So that we can have 9, n is 9, number of 9 plus 1 over 2 over 2. So we have the 5th position. So it means the median falls at the 5th position, or the 5th observation. So where is the 5th observation? 1, 2, 3, 4, 5. So 6 is the 5th observation. So we have 6 to be the median. So that is so direct. So another example is this. So we have find the median of the following set of numbers. We have 5, 15. We have 5, 15, 12, 9, 5, 11, 18, 7. So solution. So we arrange first in order of magnitude. So maybe in order of ascending order from the lowest to the highest. So the lowest is 5. So we have 5, 7, 9, 11, 12, 15, and then 18. 5, they are the lowest observation. 7 is the next, 9, 11, we have 12, we have 15, we have 18. So as that. So in that regard, since we have that now, we can then then think of we have rearranged that, then what is our set now? So we can apply n over 2 since they are even. How many do we have? 1, 2. How many observations do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. 8 observation. So we can just say we have n plus 1 divided by, no, that can be 1 is not necessary. It's not necessary for us to have 1. So we have that will be n over 2 since they are even. They are even in number, n over 2. So we can just simply have okay, I think let's put plus 1. Let's put plus 1 there. It doesn't stop that. So plus 1 over 2. So we can have 8 plus 1 divided by 2. So we can have 9 over 2. And 9 over 2 will give us 4.5. That will give us 4.5. That will be equal to 4.5. So we have 4.5 as that. So in that regard, it simply means the median is between the 4th and 5th position. So since they are even, it means the median is between the 4th and 5th position. Alright, so don't mind the sound. So we can have 5. This is the 4th position here, and this is the 5th position. So between the 4th and 5th position. So we can have that to be median to be 11. 9 plus 11 over 2. 9 plus 11 is 20, and divided by that will give us 10. Alright, so we have median of group data. So to get the median of group data, we use this formula. So we use this formula to get the median of a group data. So L1 here is lower class boundary of the. Let me explain each for you. L1 is the lower class boundary of the median class. N is total number of observation. This one is frequency before of the class before the median class, and then this is frequency of the median class, and this is class size. Okay, let me write that out. L1, where L1 is usually where L1 is class boundary, class that is class. LCL is class because of time. Class boundary of the median class of median ME, short form median class, CL class. Alright, that is L1. N is number of observation. You know what N is always total number of observation. This is CFB, is cumulative frequency before the median class. Cumulative frequency. So we know what cumulative frequency is. So what is the cumulative frequency before the median class? Before we get to the median class, what is the cumulative frequency? That's just the meaning. So cumulative frequency before median class, and then we have our FM. The FM is frequency of median class, frequency of median of the median class, frequency of the median class, and then we have C. C is the class size, class size. Yeah, the class size. You know what class size is. Alright, so that's just the explanation of each of them. So let me clean that. Oh my god, this sound is irritating. Alright, now I'm not living on an estate. So that. So don't forget the formula. So we can have now a method of group data continues, measure of group data continues as well. We have an example. So the following are the length of 50 planks cut by a machine in the following processing factory of Kara Sawmills Nigeria Limited. So we have set of observation. Wow. So we have the following set of observation. We have 30, 33, 49. You can pause the video and go through the set of observation. Alright, we have the question. Using class intervals 21 to 30, 31 to 40, control the frequency table. So we have to find the mean, and as well, and define the class, the media class. We have to define the media class. So estimate the median of the distribution. Alright, so we have the solution here, and we have the solution. Alright, so we have the table here. So when we have the class, these are the class interval. You can go back to that aspect and do that yourself. So these are the class interval here up to 100. So we have the tally number of times the division occur. Okay, so this will be the bundle here. This is a bundle. This as well is a bundle. This is a bundle. Since it's 9, these are bundle, which make them 5. So this as well is a bundle. So very good. So we have that now. So we have that. So we have the frequency. So this is 2, this is 6, 9. I think you can do that. That has been explained before. Like we have 9, we have 11 here, we have 6, 4, and 3. So the summation is 50 observation. So midpoint, which is our x. So you sum this and divide by 2. Sum them, sum a class interval and divide them by 2 each. You get our x value. Fx, you multiply this together 2 times 6, 6 times 6, 5 times 6, 9. So you get each of the fx and you sum that. That will give us 2975. Alright, we have our cumulative frequency. How do you get a cumulative frequency? That has been explained before. 2, then 2 plus 6, 8, 8 plus 9, 17, 17 plus 9, 26, 26 plus 11, 37, 37 plus 6, 43, 43 plus 4, 47, 47 plus 3, 50. Alright, so now let's get B. So we have been able to get the frequency distribution table, which is A. A has been answered. So B, our mean will then be arithmetically will be summation Fs over summation F. Summation Fs is 2975 and summation F is 50. So 2975 by 50 will give 59.5. Alright, so that is on that aspect, and that will be equal to 59.5. Okay, so we, as we have C, question C, we can have we have our median class. So what is the median class? We have to apply our formula, which is n plus 1 divided by 2. So n plus 1 divided by, what is n is 50 plus 1 over 2. That will be equals to 51 over 2. That will give us 25.5 position. So the position at the 25.5 position. So between 26 is our median class. So to get that class, you go back to your CF. Where does 25.5 falls out of everything you have here? So where we have 25.5 is this. 25.5 is here. So that means this class here is our median class. So our median class will be this 51 to 60. Yeah. So that will be our median class. So that means the median class is equal to 51 to 60. So that will be the median class. Alright, so we have now to get our median, since we have to apply that, we have to apply the formula L1, lower class boundary of the median class, plus n over 2 minus CFB, which is cumulative frequency before the median class, over FM, frequency of the median class, multiplied by its class size. Okay, so we can have that. Our L1 is 5.5, lower class boundary of the median class. So lower class boundary here of this class is 50.5. you know how to get that has been explained earlier on. N is 50, number of observation. Cumulative frequency before the median class is 7 as well. So our frequency of the median class is 9. So where is the median class frequency? Is 9. So this is it here. Frequency of the median class is 9. Alright, class size so is absolutely 10. How do we get 10 as our class size? Is different between the upper class boundary. Let's use the median class, which is 60.5. It's like upper class boundary is 60.5 minus lower class boundary, which is 50.5. So 50 point, that the difference will give us 10. So the difference gives 10. So and that will be equal to 10. As simple as that. So we can solve. You can simply solve that now. So apply the formula L1 now. L1 is 50.5 here plus N is 50 over 2 minus CFB, cumulative frequency before. Cumulative frequency before the median class. These are median class here. Cumulative frequency, this is a median class. This is the class before the median class. So its cumulative frequency is 17. So CFB is for 17. That is how we call our CFB. So minus 17 over frequency of the median class, FM is 9, multiplied by class size. Class size is 10. So you can solve that. No, 50 over 2 is 25. No, you take your time, write this plus 50 over 2 is 25 minus 17 over 9 multiplied by 10. So you find the difference first. You have to make use of a board mass, then use this 50 plus 0.5 plus subtract this 25 minus 17 will be 8 over 9 times 10, and that will give us 50.5 plus multiply this, that will be 8.89, and sum that will give us 59.39. So alright, so that has gone. We have our mode. Mode is the observation with the highest frequency, or the highest occurrence observation is your mode. So we have mode of a set of numbers is the value which occurs with the greatest frequency. The number with the highest number of occurrences is our mode. So let's take an example. So here we have look at the set. We have 2, 2, 5, 7, 9, 9, 9, 10, 10, 11, 12, and 18. So the set of observation here has the mode to be 9. Why? 9 occurs 3 times. No any other set that occurs 3 times. 2 just occurs 2 times here. 5 just once. 7 is once as well. 10 is twice. 11 is once. 12 is once. So the highest number of occurrence there is 9. So 9 will be the mode of the observation. Okay. Alright, look at here. Compute the mode of the following distribution. So you have the these are the sets of distribution here, and this is the frequency, the number of times they occurs. So which distribution here has the highest number of occurrence? Is 15, is 25. Number of times 25 occurs as a set of number is 15 times. So automatically it becomes the mode. So the mode is 25 as well. So mode of group data. To find the mode of group data, we have the formulas here to use. You can use either of this formula or this. So we have L1 plus delta 1 all over delta 1 plus delta 2, everything multiplied by class size. Alright, so let me explain each of them. Alright, so what is L1? I think in our idea of our median, getting the median of group data, our L1 is defined as lower class boundary. That will be lower class boundary. It's defined as lower class boundary. Lower class CL boundary. Let me just take it as OB of the modal class. So our modal class. Modal class is the class with the highest frequency of the modal class. Modal class. So modal class. Alright, so delta 1, our delta 1 is frequency of modal class. Frequency frequency of modal class, let me call that fm minus frequency of the class before modal class, let me call that f1. So theta 2 is as well frequency of modal class fm, let me call that fm, minus frequency of the class before modal, after modal class f2, after modal class f2. So this is that. So when we put this into this formula, we get this formula. So we can use either of the two. This. Let's take an example. So we have the distribution, the frequency distribution of marks by 60 students of a class in a college is given below. So we have the marks here, so in a class, and we have the frequencies. We have their frequencies as well. So we are asked to find the mode of this distribution. So we are asked to get the mode. So study that basically. So you have frequency distribution of marks obtained by 60 students here. So these are the classes here, and these are frequencies. So classes of marks here. We can simply have our solution. So okay, so we have our modal class. The class with the highest frequency is 45 plus 249. You can go back and check. That is class with the highest frequency. So the lower class boundary of the class. So we're using this mode formula. So we have our lower class boundary to be 44.5, as you know what that means. So we have our theta 1. That means frequency of the modal class is 18 and minus 12. Frequency before the class of the modal class is 12. So 18 minus 12 is 6. And as well, this theta 2 is 18 minus 14. That will be 4. The frequency of the class before the modal class is 14. You can go back and check how we get this, and class size is what is 5. Just you know how to get that. That has been explained earlier on. So you apply your formula. We have 44.5 plus 6 over, since theta 1 is 6 over 6 plus 4 multiplied by 5, which is the class size. So we can get that. So we can, that will be 6 over 10. 6 plus 4 is 10. 6 over 10 times 5, 44.5. We have that to be 44.5 plus 3. So 6 over 10 times 5 will give us 3. So we can sum that. Both months you need to multiply 4 before you add. So we can, that will be 47.5. So if you don't want to use this formula, we can use this other formula I stated earlier on. You can use this other formula. Where mode is equals to L1 plus frequency of the median class, of the modal class minus frequency of the class before modal class, over 2 times frequency of the modal class minus frequency before the modal class and frequency of the class after the modal class multiplied by class size. So we have each of them. So frequency of lower class boundary is 44.5. Frequency of the middle class is 18. Frequency before the middle class is 12. Frequency after the middle class is 14, and class size is 5. So that's explained that. That means our mode will be 44.5 plus 18 minus 12 over 2 times 18 minus 12 minus 14. Yeah, 12 is the class frequency of the class before modal class. So frequency after is 14. So multiply by 5. Alright, so that will simply give us 6. 2 times 18 is 36 minus 12 minus 14 times 5. So we can have 14.5 plus 6. 36 minus 12 minus 14 will give us 10 times 5, and that will give us 3. So that will give us 44.5 plus 3, and that will give us 47.5. I think that is very easy. Alright, another aspect now we can move to now is look at the relationship between mean, median, and mode. Alright, empirically we actually, it has always been stated that the differences between the mode, median, and mean is that the difference between the mean, empirically the relation between the mean, median, and mode has been stated to be that the difference between the mean and mode is usually 3 times the difference between the mean and median. That's really what I'm saying. That's empirical. Just take it that okay, in any distribution, differences between the mean and median and mode rather would be approximately be equals to 3 times difference between the mean and median. So just take it that is just the relation between them, and it's always been tested that. Alright, so these are So we come to the end of the class by giving you some practice questions. We have just 4 of them. Pause the video, you can pause that and try taking the question. Calculate the mean, median, mode of the following set of data. You have that here. So in the statistical test, 7 students scored 10 marks, 18 scored 15 marks, 4 students scored 5 marks, 6 scored. So you are given the marks together with their frequency. So just you can draw a table and put the corresponding marks together with their with the frequencies and find the mean. You get the FS and get your L summation FS and get your summation F and get that. So that is the hint on that. So yeah, you are given the distribution here. You are asked to compute the mean, median, and mode. That means you need to get the frequency distribution, form a frequency distribution, and be able to get that. Alright, so yeah, you have the score shown below here. So you have that. So you are asked to construct the frequency distribution table using the class interval of size 10. Determine the median, mode, the mean, median, and mode. So yeah. Alright, so that will come to the end of the class. So see you next time. Take care.